Okay, so in this little lecture or little mini lesson, I'm going to look at Z-scores. So what is a Z-score? So let's consider two tests. My first maths test and my second maths test. Now in my first maths test, I scored a mark of 70 and the mean was 50 and the standard deviation of the test results was 20. So now a Z-score, and in my second one, I scored a 60, the mean was 50 again, but in this case, the standard deviation was 5. So that the marks in the second test were a lot closer. So the Z-score gives me an opportunity to compare these two marks. In which test did I actually beat more students? So if we look at a Z-score in this, and the Z-score is always the same, it is my score minus the mean divided by the standard deviation. So in this case, it was 70 minus the 50 divided by 20, which gives a Z-score of 1. So I am 1 standard deviation higher than the mean. Now, in the second test, it is my score, or the data point, minus the mean over the standard deviation. Now, that's the formula that we see Alan using all the time, the score minus the mean divided by the standard deviation. So in this case, my score was 60 minus the average of 50 divided by the standard deviation of 5. So in this case, my Z-score is 2. So in the first case, I was 1 standard deviation above the mean, and in the second case, I was 2 standard deviations above the mean. So in this test, my Z-score is 2, and in this test, my Z-score is 1. So I've gone better in the second test. If we look at it in terms of the graph, this blue line is the first test. So it has a mean of 50 and a standard deviation of 20. So here's where my mark was in the first test. 1 standard deviation above the mean. This is 1 standard deviation above the mean. In the second test, in the dotted line, I'm right up here. Even though I only scored 60, there is 1 standard deviation above the mean. There's my second standard deviation above the mean. And if you look at, so this one's got a Z-score equal to 2, and this one has a Z-score equal to 1. So in this second test, I'm right up near the tail. There's not that many people in this little area of the graph here, where in that first test, there's a few more people in this area of the graph here. So that's why we use Z-scores, to be able to compare. Now, I've used nice simple numbers, and maybe some of you have heard that whole thing where 68% of people lie within 1 standard deviation either way, and 95% in 2 standard deviations. Now, these are approximates, and we'll look at them from the table. But in this case, in the first case, I was 1 standard deviation above the mean, and in the second case, I was 2 standard deviations. Now, I've obviously used very simple numbers here, but any number would have been okay to use. If in this second test, I suddenly went back and found out actually I got 61 instead of 60, how would I find my mean, my Z-score? My Z-score would be my score again, 61, minus the mean of 50, divided by the standard deviation. So 11 divided by 5, which is 2.2. Okay, so the 1 extra mark moves me to 2.2 as a Z-score, and that way I can compare the different results or my different performances in the 2 tests. Hope that's cleared up Z-scores a bit. Thanks. Bye. I'll get it off in a minute too.